All right, guys, we're going to move on to something a little bit more complicated, but not too bad. It's going to be more of the same. We got more resistors here this time, and we got different values than just getting all the resistance values and the total voltage. This time, instead, we got the total current, and we don't have the resistors for some of them. We have voltages. So we got the voltage drop across a couple of the resistors. So, let's go ahead and take a look at it and see what we can fill in from what we got so far. So based on the information, let's go ahead and punch it into the chart here. Now we know we got 25 amps total current in the circuit, so in the current category, let's go ahead and punch that in. And then we have one value for each of the resistors, but it's not resistance for all of them. So on resistor 1, they actually gave us the resistance, so we got 10 ohms on that one. Resistor 2, we have 5 volts instead. Resistor 3, we got 12.5 volts. And then on resistor 4, we're back down to the resistance value, so we got 5 ohms. Resistor 5, we got 15 ohms. So right now we don't have enough information in any one of the categories to go ahead and use Ohm's law to solve some of these. But we do have a couple of the rules we know that apply to the series circuits, which is the current should be the same across all these resistors. So again, all we can do here is just take that value and carry it over. Now we made it real easy on ourselves. Now we actually got enough information in every category except for the total. So we're going to use Ohm's law a little bit differently depending on which resistor we're looking at because we have different information for each of these. So for example, for resistor 1, we have the current and the resistance. So with Ohm's law, we're going to be multiplying those values. So 25 amps times 10 ohms is going to give us 250 volts. Now we got volts and amps on the next one. So we're not going to be multiplying here. Based on Ohm's law, we're going to be dividing. So we're going to take the voltage, 5 volts divided by 25 amps, and that's going to give us a value of 0.2 ohms. For the following one, resistor 3, we got 12.5 volts divided by 25 amps, gives us 0.5 ohms. Now we're back to resistance and current. So we got 5 ohms, and we're going to go ahead and multiply that by the 25 amps, and that's going to bring us up to 125 volts. Resistor 5, we got 25 amps and 15 ohms, so 25 times 15, that gives us 375 volts. Now, makes it pretty easy here because we can add up all these values because we know that the voltage drops across each series resistor is going to give us our total voltage. And then now that we have all the resistance values, we can add each resistance value to each other, and that can give us our total resistance values. Now, these only work in series circuits, so remember to keep your rules straight when we start combining them later. So 250 plus 5 plus 12.5 plus 125 plus 375 gives us 767.5 volts. Now if we add up the resistance, we're going to take 10 plus 0.2 plus 0.5 plus 5 plus 15, which gives us 30.7 ohms. Now we got all the information here, but we do have a couple ways we can go ahead and check our work if we wanted to make sure we didn't make any mistakes, calculator errors or anything like that. So this one, the total, we never used Ohm's law to find those values. We just added them up based on the rules we know on series circuits. So let's go ahead and verify our work here and make sure that if we do apply Ohm's law, it does in fact give us that answer. So you can do it any way you want. I'm going to go ahead and multiply 25 times 30.7, which is the resistance times the current, and that should give us a voltage of 767.5 volts. So I think you guys are doing pretty good. Just go ahead and keep plugging away and finishing the assignments. A lot of this is just repetition. It's like when you're learning your multiplication tables, just do it over and over, and after a while, it's going to be second nature. So keep practicing, and we'll check back in with you guys again later. All right? Thanks.